Welcome back to a new session of MOOC on Information Security, User Authentication. From the previous sessions, we have acquired the knowledge that authentication is an important part in information security. This session will focus the user authentication and its implementation mechanisms. What is user authentication? User authentication verifies the identity of a user attempting to gain access to a network or computing resource by authorizing a human-to-machine transfer of credentials during interactions on a network to confirm a user's authenticity. Authentication helps ensure only authorized users can gain access to a system by preventing unauthorized users from gaining access and potentially damaging systems, stealing information or causing other problems. Almost all human-to-computer interactions other than guest and automatically logged in accounts perform a user authentication. It authorizes access on both wired and wireless networks to enable access to a networked and internet connected systems and resources. A straightforward process, user authentication consists of three tasks. First one is identification. Users have to prove who they are. And the next is authentication. Users have to prove that they are who they say they are. And the last is authorization. Users have to prove they are allowed to do what they are trying to do. There are two definite authentication services described in X.800, which is as follows. Peer entity authentication. It supports for the collaboration of the identity of two entities cooperative in communication. Peer entity authentication is supported for use at the formation of or at times during the data transfer procedure of a connection. It can try to support confidence that an entity is not implementing, such as masquerades or an unapproved reply of a previous connection. Data origin authentication. It supports for the validation of the sources of a message or sender. It does not support protection against the duplication or modification of information units. This type of service supports applications such as electronic mail, where there are no previous interactions among the communication entities. Factors used for user authentication. The main factors used in user authentication include the following. Knowledge factors include all things users must know in order to log in to gain access to a system. Usernames, IDs, passwords and personal identification numbers or PINs are all fall under this category. Possession factors consists of anything users must have in their possession in order to log in. This category includes one-time password tokens, key fobs, smartphone apps and employee ID cards. Inherence factors include characteristics inherent to individuals that confirm their identity. This category includes the scope of biometrics such as retina scans, fingerprint scans, facial recognition and voice authentication. Other factors include location and time factors, which are typically used together or in conjunction with another authentication factor. Location factors are a method of confirming users' identity through their location. User authentication systems accomplish this by using the built-in global positioning system or GPS functionality of most smartphones to identify a person's location or combine Wi-Fi and cell tower triangulation to estimate a location. Authentication systems typically do not use location on its own to confirm identity. For example, if an attacker logs in with a user's password and the location factor can prevent the attacker in a different geographical area from posing as the user who typically logs in only from a specific location. Here, the location and password are used together to confirm identity. Time factors. Add time-based focus characteristics to confirm identity. Similar to the location factor, the time factor is not adequate on its own but can be helpful when used with another factor. For example, if a system last authenticated a user at noon in the US, an attempt to log in an hour later from Asia would be rejected based on the combination of time and location. A time factor can also only permit access within a scheduled time interval. Single factor authentication, two-factor and multi-factor authentication. Single factor authentication SFA. Single factor authentication or SFA requires verification of one piece of information from a user such as a password. Because SFA commonly employs knowledge factors which require only a single piece of information, it can't stop an attacker who has stolen a user's password from accessing a user's system. Advantages of the single factor authentication system. It is very simple to use and straightforward system. It is not at all costly. The user does not need any huge technical skills. Disadvantages of the single factor authentication are: it is not at all password secure. It will depend on the strength of the password entered by the user. The protection level in single factor authentication is much low. Two-factor authentication TFA. In this authentication system, the user has to give a username, password and other information. There are various types of authentication systems that are used by the user for securing the system. Some of them are wireless tokens, virtual tokens, OTP and more. Advantages of the two-factor authentication. The two-factor authentication system provides better security than the single-factor authentication system. The productivity and flexibility increase in the two-factor authentication system. The two-factor authentication prevents the loss of trust. Disadvantages of two-factor authentication. It is time consuming. Multi-factor authentication or MFA. Multi-factor authentication uses more than one method of authentication to verify the identity of a user. For example, a user may be required to provide a password in combination with a security question. Two-factor authentication uses factors from two of the authentication categories, while four-factor authentication uses at least one factor from four categories of factors. The latter is considered for more secure due to the additional layers of security that come with more factors. Advantages of multi-factor authentication system. No risk of security. No information could get stolen. No risk of any key logger activity. No risk of any data getting captured. Disadvantages of multi-factor authentication system. It is time consuming and it can rely on third parties. Common authentication types. The list below reviews some common authentication methods used to secure modern systems. Password-based authentication. Passwords are the most common methods of authentication. Passwords can be in the form of string of letters, numbers or special characters. To protect yourself, you need to create strong passwords that include a combination of all possible options. However, passwords are prone to phishing attacks and bad hygiene that weakens effectiveness. An average person has about 25 different online accounts, but only 54% of users use different passwords across their accounts. The truth is that there are a lot of passwords to remember. As a result, many people choose convenience over security. Most people use simple passwords instead of creating reliable passwords because they are easier to remember. The bottom line is that Passwords have a lot of weaknesses and are not sufficient in protecting online information. Hackers can easily guess user credentials by running through all possible combinations until they find a match. Certificate-based authentication. Certificate-based authentication technologies identify users, machines or devices by using digital certificates. A digital certificate is an electronic document based on the idea of a driver's license or a passport. The certificate contains the digital identity of a user, including a public key, and the digital signature of a certification authority. Digital certificates prove the ownership of a public key and issued only by a certification authority. Users provide their digital certificates when they sign into a server. The server verifies the credibility of the digital signature and the certificate authority. The server then uses cryptography to confirm that the user has a correct private key associated with the certificate. Biometric authentication. Biometric authentication is a security process that relies on the unique biological characteristics of an individual. Here are key advantages of using biometric authentication technologies. Biological characteristics can be easily compared to authorized features saved in a database. Biometric authentication can control physical access when installed on gates or doors. You can add biometrics into a multi-factor authentication process. Biometric authentication technologies are used by consumers, governments and private corporations including airports, military bases and national borders. The technology is increasingly adopted due to the ability to achieve a high level of security without creating friction for the user. Common biometric authentication methods include facial recognition, matches the different face characteristics of an individual trying to gain access to an approved face stored in a database. Face recognition can be inconsistent when comparing faces at different angles or comparing people who look similar like close relatives. Facial liveness like ID/RND's passive facial liveness prevent spoofing. Fingerprint scanners match the unique pattern of an individual's fingerprints. Some new versions of fingerprint scanners can even assess the vascular patterns in people's fingers. Fingerprint scanners are currently the most popular biometric technology for everyday consumer despite their frequent inaccuracies. This popularity can be attributed to iPhones. Speaker recognition, also known as voice biometrics, examines a speaker's speech patterns for the formation of specific shape and sound qualities. A voice protected device usually relies on standardized words to identify users just like a password. Eye scanners include technologies like iris recognition and retina scanners. Iris scanners project a bright light towards the eye and search for unique patterns in the colored ring around the pupil of the eye. The patterns are then compared to approved information stored in the database. Eye-based authentication may suffer inaccuracies if a person wears glasses or contact lenses. Token-based authentication. Token-based authentication technologies enable users to enter their credentials once and receive a unique encrypted string of random characters in exchange. You can then use the token to access protected systems instead of entering your credentials all over again. The digital token proves that you already have access permission. Use cases of token-based authentication include RESTful API that are used by multiple frameworks and clients. Transaction authentication. Transaction authentication takes a different approach from other web authentication methods. Rather than relying on information the user provides, it instead compares the user's characteristics with what it knows about the customer, looking for discrepancies. For example, Say an online sales platform has a customer with a home address in Bangalore. When the user logs in, a transaction authentication system will check the user's IP address to see if it's consistent with their non-location. If the customer is using an IP address in Bangalore, all is well. But if they are using an IP address in China, someone may be trying to impersonate them. The latter case raises a red flag that triggers additional verification steps. Of course, the actual user may simply be traveling in China, so a transaction authentication system should avoid locking them out entirely. Transaction authentication does not replace password-based systems. Instead, it provides an additional layer of protection. Computer recognition authentication. Computer recognition authentication is similar to transaction authentication. Computer recognition verifies that a user is who they claim to be by checking that they are on a particular device. These systems install a small software plugin on the user's computer the first time they log in. The plugin contains a cryptographic device marker. Next time the user logs in, the marker is checked to make sure that they are on the non-device. The beauty of this system is that it is invisible to the user who simply enters their username and password. Verification is done automatically. The disadvantage of computer recognition authentication is that users sometimes switch devices. Such a system must enable logins from new devices using other verification method. Example, texted codes. CAPTCHAs. Hackers are using increasingly sophisticated automated programs to break into secure systems. CAPTCHAs are designed to neutralize this threat. This authentication method is not focused on verifying a particular user, rather it seeks to determine whether a user is in fact human. Coined in 2003, the term CAPTCHA is an acronym for Completely Automated Public Turing Test to tell computers and humans apart. The system displays a distorted image of letters and numbers to the user, asking them to type in what they see. Computers have a tough time dealing with these distortions, but humans can typically tell what they are. Adding CAPTCHA enhances network security by creating one more barrier to automated hacking systems. Nevertheless, they can cause some problems. Individuals with disabilities, such as blind people using auditory screen readers, may not be able to get past a CAPTCHA. Even non-disabled users sometimes have trouble figuring out them, leading to frustration and delays. Single sign-on SSO. Single sign-on SSO is a useful feature to consider when deciding between device authentication methods. SSO enables a user to only enter their credentials once to gain access to multiple applications. Consider an employee who needs access to both email and cloud storage on separate websites. If the two sites are linked with SSO, the user will automatically have access to the cloud storage site after logging on to the email client. SSO saves time and keeps users happy by avoiding repeatedly entering passwords. Yet it can also introduce security risk. An unauthorized user who gains access to one system can now penetrate others. A related technology, single sign-off, logs users out of every application when they log out of a single one. This boosts security by making certain that all open sessions are closed. Authentication protocols. Now that we have a sense of commonly used authentication methods, let's turn to the most popular authentication protocols. These are specific technologies designed to ensure secure user access. Kerberos and SSL TLS are two of the most common authentication protocols. Kerberos. Kerberos is named after a character in Greek mythology the fearsome three-headed guard dog of Hades. It was developed at MIT to provide authentication for Unix networks. Today, Kerberos is the default Windows authentication method, and it is also used in Mac OS X and Linux. Kerberos relies on temporary security certificates known as tickets. The tickets enable devices on a non-secure network to authenticate each other's identities. Each ticket has credentials that identify the user to the network. Data in the tickets is encrypted so that it cannot be read if intercepted by a third party. Kerberos uses a trusted third party to maintain security. It works as follows. First, the client contacts the authentication server, which transmits the username to a key distribution sender. The key distribution sender then issues a time-stamped access ticket, which is encrypted by the ticket granting service and returned to the user. Now the user is ready to communicate with the network. When the user needs to access another part of the network, they send the ticket to the ticket granting service, which verifies that it's valid. The service then issues a key to the user, who sends the ticket and service request to the actual part of the server they need to communicate with. This is all invisible to the user, happening behind the scenes. Kerberos has some vulnerabilities. It requires the authentication server to be continuously available, and it requires clocks on different parts of the network to always be synchronized. Still, it remains a widespread and useful authentication technology. SSL or TLS. Secure Socket Layer SSL and its successor Transport Layer Security TLS is another important authentication protocol. In SSL TLS, clients and servers use digital certificates to authenticate each other before connecting. Client certificates and server certificates are exchanged to verify each party's identity in a process known as mutual identification. The server certificate is a small data file saved on the web server. The certificate links a cryptographic key to the details of the organization that owns the server. A web browser checks the validity of the certificate before connecting to the server. SSL TLS support is built into all major current web browsers, including Internet Explorer, Chrome, Firefox, and Safari. This makes it easy and inexpensive to implement since it does not require special software. All traffic in SSL TLS is encrypted so that it's inaccessible to eavesdroppers. SSL TLS has become an integrated part of web technologies and continues to be refined and updated. If your clients use it, make certain that they choose a more secure TLS implementation, as SSL is out of date and has significant vulnerabilities. User authentication limitations and improvements. A number of issues affect the security of an authentication system. In addition to the number of factors involved, the specific technologies used and the manner in which they are implemented affect reliability. Well-designed and appropriately enforced implementation rules can help ensure the security of user authentication. For example, passwords, among the most vulnerable method of authentication, are relatively insecure because hackers can typically easily guess and crack them. To alleviate the problem, several industries and organizations have implemented strong password standards which insist users create passwords that meet minimum length and other requirements, such as including at least one number and letter plus a symbol, etc. The ubiquity of mobile devices and cloud computing today has greatly affected how enterprises implement authentication. In the past, a simple password authentication system was sufficient to keep networks secure. However, increased risk of data breaches has made companies re-evaluate their authentication strategies. Modern authentication processes should involve more than a single factor in order to ensure the highest level of security. When improving and encouraging users to improve passwords, here are a few things to keep in mind. Longer passwords are more secure. Security experts suggest that you create passwords with a minimum of 8 characters. But we recommend that you create passwords closer to 12 characters in length. Passwords should have a mix of characters. Passwords with a random combination of uppercase and lowercase letters, numbers and symbols are harder to crack. Users should avoid using formulas when generating passwords. The truth is that patterns and formulas make it easy for hackers to guess your password and can offer users a false sense of security. In this session, we have discussed various user authentication methods which we are very familiar while using our social network. Hope you enjoyed this session. See you next time. Bye.